Okay, so here we are, and we want to determine the number of terms of each geometric sequence. Starting with number 1 here, 6, 12, 24, all the way up to 768. And we're going to be using this formula. AN is equal to A1 times R to the power of n minus 1. So what we're really looking for here is n for both cases, because we know A1, the first term, we know AN, and we know R also. R is just going to be any term, so maybe the second term divided by the previous. So R is just going to be 12 divided by 6, so just 2 in this case. Okay, so now we can use the formula. And 768 is going to be equal to the first term times the ratio R, which is just 2, to the power of n minus 1. Okay, so now we want to figure out what n is, and I can divide both sides by 6. So 768 divided by 6 is 128. And that's equal to 2 to the power of n minus 1. Okay, so here we have two choices. We can either use logs to determine this and solve the equation, or we can just decompose 128 with a factor tree and discover that 128 is 2 to the power of 7. So 2 to the power of 7 is equal to 2 to the power of sorry, to the power of n minus 1. So 2 equals 2. So 7 is going to be equal to n minus 1. Just going to continue down below here. So you can add 1 to both sides of the equation. So n is 8. So the first sequence has 8 terms. That's the 8th term. Now let's try this guy. So from 40 goes down to 20, all the way down to 1.25. Alright, so our first term is just 40. AN is 1.25. Let me make that into a fraction. That's equivalent to 125 over 100. And 125 over 100 is 5 over 4. Alright, so now let's determine R. And R is just going to be any term divided by the previous. So 20 divided by 40 will be just half. Great, now we have all components except for n. We're going to use the same formula. That was a terrible looking arrow. There we go. So that's going to be just 5 over 4 equals the first term, which is 40, times half to the power of n minus 1. And we want to solve for n. Okay, so now what I can do is that I can multiply both sides by 1 over 40. 1 over 40. That way I can cancel these out. And over here, 5 over 40, I can just divide top and bottom by 5. So I get 1 over 8. So we just get 1 over 8 times 4, 32. Right, because we multiplied top. 1 times 1, 1. 8 times 4, 32. Equals half to the power of n minus 1. And 32, remember that 32 is just 2 to the power of 5. So I can rearrange this fraction and say that we have half to the power of 5 is equal to half to the power of n minus 1. So these guys are the same. So are these. So 5 is equal to n minus 1. Now I can add 1 to both sides of the equation. These guys cancel out. And n is equal to 5 plus 1, just 6. So this is the 6th term of the sequence. And that's it.